Hi guys, so in this lecture, I will present an overview of object detection algorithms, which include RCNN, fast RCNN, faster RCNN, and mask RCNN. We will look at the key takeaways from each of the algorithm and the primary challenges associated with each of the algorithm. So following are the objectives, or you can say following are the topics which we will cover in this lecture. The first one is convolution neural network. We will not go into much details regarding convolution neural network, like what is the activation function in the convolution neural network, what are the kernels, and why we use dense layer and other things. We will be only focusing on why we use convolution neural network and why can't we use convolution neural network for object detection. Next, we will discuss about RCNN. We will see what is RCNN and what is the primary goal of RCNN. How we can implement RCNN and what are the primary challenges associated with RCNN. Next, we will discuss about fast RCNN and the primary challenges associated with fast RCNN. Next, we will look at faster RCNN. How faster RCNN is different from RCNN and fast RCNN, why and what is region proposal network in faster RCNN, and last we will see what are the key takeaways from the faster RCNN and why we need mask RCNN, and in the last we will also look at mask RCNN and its working. So now we will look at the convolution neural network. So convolution neural network works best if we want to do image classification. For example, if there is a cat or a dog in the image, or if we want to do multi-class classification, like is there a cat, dog, person, deer in the image. So there are 4 classes. So if there are even 10 classes, convolution neural network works best. Convolution neural network works best for image classification. So what basically image classification is, let me explain over here. For example, we have this image and for example, we have a cat in this image. Okay, so with image classification, we will have the output as like we have the cat in the image, or if we have multiple objects in the image, we will have the output like cat, dog, person, and like this is the output we get using convolution neural network for image classification. But in case of object detection, we need to figure out where is the specific object in the image. Like we need to find out where is the cat in the image. So in the case of object detection, we need to draw a bounding box, like this bounding box around the cat in the image. So why can't we use object detection, or why can't we do object detection using convolution neural network? You might be thinking this. Okay, so if we have a single object in the image, then we can use convolution neural network for object detection. Like here we have only a single object in the image. Here we can use convolution neural network for object detection. But if we have multiple objects in the image, we can't use convolution neural network for object detection. But if is there a way out? You might be thinking, yes, there is a way. You can use convolution neural network for if we have multiple objects in the image, but this will not work. This will fail. This approach will fail if you try, because we can't use convolution neural network for object detection if we have multiple objects in the images or video. But if you try to do it, like I have listed over here, one way to do object detection using CNN is to divide our image into smaller grids, blocks or grid. For example, this is my image, and here I have multiple objects, like these are the 2 objects and this is the 3rd object. So I will divide my image into multiple grids. Like let me change the color for grids. So here I am dividing my image into multiple grids, like this is 1, 2, 3. So we have divided our image into 3 cross 3 grids. Okay, so one way to do object detection using CNN is to divide our image into smaller grids. But if we have object of different sizes image, like we have different objects, multiple objects, like 70 objects or 10 objects in image, and all of the objects are different sizes, we can divide image into 1000 cross 1000 grid. Like this is here we have divided image into 3 cross 3 grid, Now we can divide image into 1000 cross 1000 small grids, but it will definitely become computationally expensive. Like if you try to run this script on GPU, your system will crash, GPU will crash. So this will not be big work. We can use CNN for object detection, but if we have a single object in the image. But if we have multiple objects in the image, CNN fails for object detection. CNN works best for image classification, but CNN can't be used for object detection if we have multiple objects in the image. Now, I will discuss the region-based convolutional neural network. So, let's first look at the goal of the region-based convolutional neural network. The goal of the region-based convolutional neural network is to take an input image and currently identify where are the objects in the image via bounding box. So, let me explain you what basically is this. For example, this is my input image. Okay, so let me change colors. So for example, this is my object number 1, this is my object number 2, this is my object number 3, this is my object number 4. So this is my object number 5. So I have 5 different objects in the image. So the goal of region-based convolutional neural network is to take, this is my input image. Okay. So region-based convolutional neural network will take this input image, and in the output we will get the objects with bounding box. Like through region based convolutional neural network, we can identify where are the objects in the image via a bounding box. So in the output we will get, so output, in the output we will have the bounding box around each object. Like this is the bounding box for 3 objects, this is the bounding box for the 4 objects, this is the bounding box for the 5 objects. So region-based convolutional neural network takes an input image, and in the output it correctly identifies where are the object in the image via a bounding boxes. So how it works: input image is passed, while in output we have the bounding boxes plus label for each objects in the image. Like this can be a dog, this can be the cat, so these are the labels for cat, and this can be a cow, or this can be a camel, or this can be a sheep. Okay. So region-based convolutional neural network was proposed in 2014 by Ross, Gershik, and other team members. What RCNN is, how RCNN basically work? RCNN basically what RCNN does, it divides the image into a number of boxes instead of grids. Okay, so instead of dividing the image into grids, like what is basically grid is, like in we divide the image into grids like this. These are the grids we are creating. So in RCNN we don't do this. So this approach isn't followed in RCNN. So RCNN basically divide the image into a number of boxes instead of grids, like you can see over here. Just highlight it. Okay, where is the highlighter? So you can see over here, in RCNN we divide the image into number of boxes instead of grids. So RCNN uses selective search algorithm to extract 2000 regions from the images. So in RCNN, using selective search algorithm, we extract 2000 regions from the images called region proposals. Okay, in RCNN, we identify different regions in the image and then pass it to the feature extractor, which is convolutional neural network. So for example, in RCNN, we don't divide our image into grids. So let me explain this point to you. So for example, here we have the image in RCNN, and this is the object in the images. So in RCNN, we will divide our image into 1000 boxes. Like here we have a one box, here we have another box, here we have another box. Okay. So in RCNN, we using selective search algorithm, we extract 2000 regions from the images called region proposals. And after extracting 2000 regions from the images, we pass it to the feature extractor of the convolutional neural network. So this is what we do. That is why it is called region-based convolutional neural network, because we extract 2000 regions from the images, which are called region proposals. So this is how RCNN works. So region-based convolutional neural network is based on the following steps. Like we generate a set of region proposals using selective search algorithm for the bounding boxes. Like we basically have an input image, then we select 2000 regions from the input image, and then we pass the 2000 regions we selected from the input image through the CNN feature extractor to extract the image. So basically CNN feature extractor here is uh, pre-trained AlexNet. Okay. Then we have an SVM to see what object the image has in the bounding boxes. Like now uh, after having it in passing it after getting 2000 regions from the input image and passing the image through the pre-trained AlexNet for feature extractor, and then using SVM we classify what are the different objects we have inside the bounding box. Okay, like we can have a cat, dog, cow inside the bounding boxes, and then we run the bounding boxes through a linear regression model to output detected coordinates for the boxes once the object has been classified. So using linear regression, we find the coordinates of the bounding boxes. So what are the issues with RCNN? Like in RCNN, for each image, we extract 2000 regions and then we pass to the CNN feature extractor. So when we extract 2000 regions from the image and pass it to the CNN feature extractor, this makes all the process very slow and it cannot be implemented in real time because each image takes 47 seconds to test to find to be implemented. So if each image takes 47 seconds for the processing, so this is too much time. So we can't use RCNN for in real time, because what are the issues with RCNN is that for each input image we extract 2000 regions and then we pass to the convolutional neural network for the feature extractor. So what we can do is, if we have an input image and we pass it to the feature extractor and then we select 2000 regions after the feature selective algorithm or using CNN feature selector, after passing to the feature selection algorithm, we extract 2000 regions from the images through selective search algorithm, and then we can do further processing. This can make the whole process very much better. So here is the block diagram of the region based convolutional neural network. Here we have the input image. We extract 2000 regions from the image and using CNN feature extractor, then we extract features and then we classify like there is an aeroplane, cursor or TV monitor. So the process can be made very efficient if we have this region proposal network after this CNN feature extractor. Like first we have the input image, then we have the input feature extractor, then we can have the region proposal network at the third point over here. Like we can move this over here. Okay. And then we can classify like this is aeroplane, person or TV monitor. Let's look at the fast RCNN. What basically we do in RCNN is that we identify 2000 regions in the image and then we pass it to the feature extractor, CNN based feature extractor. So what we do in fast RCNN is that we have the input image. Instead of identifying 2000 regions from the image, we send the whole image to the CNN feature extractor, and then in the feature space we have the region proposal method. Okay. So in 2015, the authors of RCNN came with the idea of fast RCNN to address the drawbacks in the RCNN. In fast RCNN, the input image is passed to the convolutional neural network based feature extractor to generate convolution feature map, and from the convolution feature map, we identify the region of proposals. The reason why fast RCNN is faster than RCNN is that we don't need to feed 2000 regions proposals to the convolutional neural network each time. Instead, the convolution operation is done once per image and the feature map is generated from it. So here we have the reasons that fast RCNN is faster than RCNN is that because we don't need to identify 2000 regions from each of the image and then pass it to the convolutional neural network. What we do is fast RCNN is that we have the input image, we pass it to the CNN feature map, and after passing it to the CNN feature map, we get that 2000 regions from the image. Okay. Block diagram of fast RCNN. So this image is passed directly to the basically convolution feature map for feature extractor. Then we have the ROI pooling layer where we extract 2000 regions from the image, and then we have the SVM function, and then we apply linear regression like all the step. But instead of getting 2000 regions from the image, we pass image directly to the convolution feature map, and then we extract 2000 regions from the image. Then are the primary challenges associated with fast RCNN, like fast RCNN perform better than RCNN, but we observed the performance of the fast RCNN during testing time slows down while using region proposal. Like uh, what it means by region proposal is that during testing time, when we extract 2000 regions from the image using selective search algorithm, so the performance of the fast RCNN during testing time gets down as compared to not using region proposals. Therefore, region proposal is the major reason resulting in the degradation of the performance of the fast RCNN. Okay. So here is the chart as well, like comparison of object detection algorithm. You can overview it further and see by including region proposals, our performance slows down, while without excluding region proposals, our performance in testing time is better. Like including region proposal, it takes 49 seconds, while excluding region proposal, it takes 47 seconds for RCNN. Okay, while with the fast RCNN using region proposal, it takes 2.3 seconds, while without region proposal, it takes 0.32 seconds. So using region proposals is a major reason that degrades over the performance of fast RCNN. Guys, RCNN and fast RCNN basically use selective search algorithm to find the region proposals, or you can say 2000 regions in the image, which basically slows down the processing of, like we have discussed that in the previous slide, in testing times using region proposals, if you use region proposal, our processing becomes very slow, and it is a quite time consuming process as well. So in faster RCNN, instead of using region proposal, like extracting 2000 regions from the images using selective search algorithm, in faster RCNN, we don't use selective search algorithm. In faster RCNN, we allow the network learn the region proposals. There is a separate layer for the region proposals in the faster RCNN. So in faster RCNN, the author made this improvement that they eliminated the use of selective search algorithm. In faster RCNN, we don't use selective search algorithm. Why? In faster RCNN, we have a separate layer for to find 2000 regions from the images. Okay, so faster RCNN is object detection algorithm which eliminates the use of selective search algorithm and let the network learn the region proposal. So we don't use selective search algorithm in faster RCNN because selective search algorithm is the major reason of slowing the processing in RCNN and fast RCNN. Similar to fast RCNN, the image is provided and as an input to convolution network, which provides a convolution feature map. So in like we do in fast RCNN is that the workflow of fast RCNN and faster RCNN is same. Like in fast RCNN, we have an input image and then we pass to the convolution neural network based feature map. So the same we do in faster RCNN as well. Like in faster RCNN, the image is provided as input to a convolution neural network, which provides a convolution feature map instead of using selective search algorithm. So in faster RCNN, we use selective search algorithm. While in faster RCNN, we don't use selective search algorithm on the feature map to identify the region proposal. Instead of, in faster RCNN, we have the region proposal network. Okay. So in faster RCNN, we use region proposal network instead of selective search algorithm to identify 2000 regions in the image. Okay. Architecture of faster RCNN. As you can see here, in faster RCNN, we don't use selective search algorithm. Instead of, we have a separate layer which is used to find 2000 regions in the image. Okay, so using region proposal network layer, this is the layer which find 2000 regions in the image. So this is the difference between faster RCNN and the prior algorithms. following are the key takeaways from the faster RCNN. Like in RCNN, fast RCNN, we use selective search algorithm to find the region proposals, which makes the processing very slow as we have seen in the previous slides. In faster RCNN, we do not use selective search algorithm. Instead of faster RCNN, directly let the network learn the region proposals, which means it directly allows the network to find 2000 regions in the images instead of using selective search algorithm. In faster RCNN, a separate network is used to predict the region proposals instead of selective search algorithm. So what are the primary challenges with faster RCNN? Faster RCNN gives the bounding boxes only, but no semantic segmentation. For semantic segmentation, we will use mask RCNN. Let's move towards the mask RCNN. Okay, mask RCNN. Mask RCNN is built using faster RCNN. The main idea behind mask RCNN is to extend faster RCNN to pixel level segmentation. In addition to bounding boxes and class label, in mask RCNN, we have an object mask on our output. Like for example, if we have a person in our output, which we have a bounding box drawn around the person, so we have a mask as well on it. So instead, in addition to bounding boxes and class label, mask RCNN outputs an object mask as well. In mask RCNN, a fully convolutional neural network is added at the top of CNN features of faster RCNN, which generate the mask output. Mask RCNN uses a trick called ROI align to locate relevant areas down to pixel level. The backbone of mask RCNN is SNet 101. This is an overview of output of mask RCNN. Like here you can see that we have detected car. We have a mask on the object like car as well. Now here we have detected a person. Now you can see that we have a mask on the person as well. Like there is a mask. Plus we have a label as well for the person. Plus here we have the traffic light. We have detected traffic light and we have a mask on it as well. And you can see here we have also detected a traffic light and we have a mask on it as well. And here we have the bounding box and this is the confidence score. So this is the label, the confidence score and the mask on the object here. So now let's see where we can use mask RCNN. Mask RCNN is used in Detectron 2. So Detectron 2 is a framework and main model used in Detectron 2 is mask RCNN. To use mask RCNN in PyTorch, it requires Detectron 2. Mask RCNN backbone is ResNet 101. Mask RCNN is used for instant segmentation and UNet is a great framework and Usenet is used for semantic segmentation. In the previous slide, I might have mistakenly told you that mask RCNN is used for semantic segmentation. Sorry for that. Mask RCNN is used for instant segmentation and UNet is used for semantic segmentation. For watching this video tutorial. See you in the next video tutorial. Till then, bye bye.